Alright, so let's go ahead and continue what we're doing with our video solutions for the retake of exam 2. So we're going to throw a stone vertically upward at 20 meters per second from the top of a roof that's 30 meters high. We're going to find the speed of the stone before it hits the ground and the time it takes to hit the ground. So this is interesting. We start here, throw the stone up, and then it lands. So first, let's get the time it takes to go to its maximum height from the roof. So what we're gonna do is this. We're gonna do this part first, from here to here, and then we're gonna do this part second, from here down to here. And I'm gonna do those in two different colors, just so you can see it. So part one, we are going to go ahead and let me just get that height that it goes to, and let me find the time it takes. So I have v equals negative gt plus v naught. So let's get the time it takes to get to its maximum height. That's going to be 0 equals negative, and you know what? I'm going to round g to 10 for the sake of these calculations. On free response, I'll let you do that. So negative 10 times t plus 20. So t ends up being 2 seconds to reach that height. Okay. Now let's actually get what that height is. So the height is going to be v squared equals v naught squared plus 2 times g times y minus y naught. And that's going to be 0 equals 20 squared, which is 400, so you got to keep an eye out for that, plus 2 times negative 10 times y minus, let's get that final height it goes to. So it starts from an initial height of 30 meters. So what that means is negative 400 divided by negative 20 equals y minus 30. And what that means is negative 20 equals y minus 30. Did I get this right? No, positive 20 equals y minus 30. So y ends up being 50 meters high. Awesome. Now, so far we've got 2 seconds to go up. Now let's get the time to fall back down to the ground from 50 meters high. So we have y equals 1/2 gt squared plus 0 plus 50. And so we have actually negative 50, because this ends up being 0, the y final 0, is negative 5 times t squared. So t ends up being the square root of 10, which is about 3.3, but let me just get a better number for it. So about 3.16. We'll say 3.2 seconds to hit the ground. So we've already got one answer. We know that the total time is going to be the 2 seconds plus the 3.2 seconds. So t is going to be 5.2 seconds. Now let's get the speed before it hits the ground. Sorry, this is bad. So t is going to be 5.2 seconds. Now let's get the speed. So to get that, we're going to actually say v equals gt plus v naught. So v is going to be 10 times 3.2 plus 0, or negative 10 plus 3.2 times 0. So v ends up being negative 32 meters per second. Right. Whoops. V is negative 32 meters per second right before the object hits the ground. So that's pretty good. Not bad. And you know what? I'm just going to clean this up just a little bit to make sure that we're sort of on the right page here, and that nothing gets too messed up. So that should be good. All right. Now, the figure below, this is a really good question, because what it does is it forces you to think about the equation x equals 1/2 at squared plus v naught t plus x naught. So what we're going to do is we're going to actually sit around here and try to figure out how this graph applies to this equation here using a little bit of algebra. So first of all, it looks like our initial position, we're told that xs is 6, so that makes this 4, 2, 0, negative 2. So look at that. We've already got that x naught is negative 2. Now notice we start off with a steep slope, less steep, and so we actually start off with a slope of 0 here, which tells us our initial speed is 0. So our equation that we want to get is xs equals 1/2 at squared. So let's see if we can plug in some numbers and solve. Oh yeah, sorry, -2 for the x naught. So let's plug in some numbers. Let's put in, maybe we can put in 6 here, and we can put in a t of 2 and see what we get. So we get 6 equals 1/2 times a times t 2 squared minus 2. So I'm going to end up getting 8 equals 1/2 times a times 4. So we get 2 equals 2. And I'm getting that a is, in fact, 4 meters per second squared. I'm pretty sure I got that right. I'll just double check. So 6 plus 2 is 8. And then we have 1/2. Yeah, so yeah, 4 meters per second squared is what I'm getting. Now, number 4 is a great question. I really like it because it really forces you to think. And how many did I give you on this? Nice. So I gave you some good, tough questions. And looks like I threw out one of the questions. That's good too. So now we have a subway that is going 800 meters. And let's be clear on this. Here, we're going to accelerate. And then here, we're going to negative accelerate. But our rate of acceleration is 1.5 meters per second squared. Our acceleration is 1.5 meters per second squared. So let's get the maximum speed we can acquire between stations. And then let's get the travel time. So we know that v squared equals v naught squared plus 2 times a times x minus x naught. And in this case, we have some unknown v squared equals 0 squared because we start from rest times 2 times 1.5 times x minus x naught. And of course, that's going to be 400. So let's see what we can do. V squared is going to end up being 3 times 400. So v squared equals 1200. So let's get that v. And that ends up being 34.64 meters per second. Now we can use that to get the time to travel between stations. So let's get half the time. Half the time is going to be v equals at plus v naught, and then we're going to double that. So we're going to get the time from here to here, and then it'll take double that time to go from here to here. So time from here to here equals the time from here to here. So let's go ahead and do that. So we're going to get 34.6 equals 1.5 times t plus 0. And so we're going to get a time for half the trip of 23.1 seconds. For half the trip. Therefore, for the whole trip, 46.2 seconds. So that's a really good one. Finally, for our last question, this is such an obnoxious question. We have a hot air balloon, right? And it's going up at 12 meters per second, and we drop a package off the side. Now here's the thing. If the balloon's going up, that means the package's initial speed is positive 12 meters per second. So this question is actually way easier than you think. This is how it works. We're going to actually say y equals negative 1/2 gt squared plus v naught t plus y naught. So here we go. 0 equals negative 4.9 times t squared plus 12 times t plus 80. So now we actually have to solve for t. So that's the first part. Then to get the speed that the package hits the ground at, I'm going to use the second equation, which is v squared equals v naught squared plus 2 times negative 9.8 times y minus y naught, which is 0 minus 80. So I'm going to get v squared equals 144, because that's 12 squared, plus 2. I'm going to make this about 10, just to kind of round it. So 2 times negative 10 times negative 80. So I'm going to get v squared, when I get all this done, is going to be 144 plus 20 times 80, which is 1600. So v squared ends up being the square root of 1744. So the v that I hit the ground at, when I get that number, that's going to be 41.76. And what I'm going to do actually is I'm going to actually have you solve for the time. and submit an answer to me on a Google Doc, because I just want to make sure that you guys are actually doing the work here. And you'll keep the positive time. So that's it for the Exam 2 retake solutions. And in the next set of videos, I'll do Exam 3 and Exam 3 retake.